and get started here. So if y'all want to head over, and then we'll get this show on the road. So I don't know if you all heard, but Franklin's out today. So we're just going to kind of kick it off and then hand off to the next speaker and, just kind of roll with it. So I guess if you have any questions or want to reach out to him, I guess you can hit him up on email or Meetup or whatever. So anyway, my name's Jim Saunders. I'm going to be giving the Decrypting Android Pay Tokens talk today. Here's all my info. I work at Etsy. I'm on the payments team there, and I'm one of the people responsible for making sure that all the money is flowing appropriately from buyers to sellers. So we deal a lot with credit cards, and at the beginning of the year, we rolled out Android Pay support, and I don't know if how aware you all are of Etsy, but we're primarily a PHP shop. So I wrote a PHP extension in C to do all this stuff, and then a buddy of mine was like, "Hey, you should port it over to Go." And I ported it over to Go, and it was way easier in Go than it was in C. Didn't have to deal with OpenSSL at all, which was real nice. Everything I needed was in the standard library, so it made it really, really simple. And surprisingly, the code was remarkably less than it would have been in C. So thought I'd give a talk about it, and here we are. Here's all my info if you need to reach out to me. Pretty much Jim does code in every medium possible. So what is this talk about? So we're going to be decrypting the JSON payload that's sent by Android Pay whenever somebody puts their thumb on their phone. It's going to send the JSON that's at the top there to our server, and we're going to decrypt it and turn it into the JSON that's at the bottom. You probably recognize some of the fields in the JSON at the bottom. It looks remarkably like a credit card. And for all intents and purposes, you can treat it that way. The DPAN field that you see in this in the bottom JSON is what's called a device-specific personal account number. It's basically a token for the underlying credit card that's stored in the phone. So it's not a direct one-to-one mapping of the credit card number that a user inputs into Android Pay. It's just like some derived value that looks similar to the card that the users put in Android Pay. The expirations there are pretty self-explanatory. Auth method is kind of interesting. It's currently always going to say 3DS there, and it stands for 3D Secure, which is an additional security layer that the card network set up. If some of you are familiar with Verified by Visa, I can't remember what the MasterCard one's called, but all of those use this thing called 3D Secure, and it's supposed to add some more security on. And then below that, as part of 3D Secure, there's a cryptogram, which is kind of similar to the CAVV or CCV that's on the back of your card. And they do some kind of fancy hashing and encryption on whatever this thing is. I'm not really sure how they do it. I'm not really sure what they do with it when we send it to them. But you got to send it to them, and it's an important part of the 3D Secure part. And then the last one's the ECI indicator. That just tells you if the particular bank and particular card supports 3D Secure, and there's several different levels of support there. So the indicator, the ECI value is optional, so it may or may not be present when you decrypt. It just kind of depends on what the card is. So moving on. So when when does this kind of decryption happen in the flow? So the first step is the user wants to buy something in your app, in your Android app. So they open up Android Pay. They press their thumb on the fingerprint scanner, or I can't remember if there's another way of doing Android Pay without the fingerprint scanner. But the app then sends the encrypted JSON to your servers. You decrypt it, which is the part we'll be discussing, and then you auth the decrypted data with the payment processor, and then the payment processor approves it, and then you would return success back in the app, and then later you would settle the payment on the with the payment processor. So there's a couple different nuances here. You may not always want to directly auth the card. You might want to instead do what we call tokenization, where instead of passing around raw card details all over the place, you store it and then you just return a token. And then anytime you want to reference that card, you pass the token around. That's a much more secure approach than passing around raw card details. So you might want to do that if you're not going to just directly auth the card. Also, I keep saying auth. If you're not really familiar with the flow of charging a credit card, the first thing that happens is there's an auth, and then the auth is basically asking the card networks, hey, does this person have this much money on the card to actually pay for this thing? And the card networks will then respond with like a yay or a no, depending upon if they have funds available. And then there's this additional step called the settle, which is when the money actually moves. There are some more nuances there. There are some combo ones where it just does an auth and then immediate settle. It kind of depends on your payment processor. They all kind of have their own little tricks for doing that kind of stuff. But that's kind of what how the flow works when it comes to actually moving money with a credit card. Auths are also when you look in your credit card statement when it shows like a pending, but it doesn't show up like on the actual statement line items. That's because something has been authed and then not settled yet. So anyway, going back to the flow, so where should the decryption happen? The data flow kind of looks like this, where you have an Android device, and then it sends data to another server, which should be PCI compliant, and then that server should then forward the data on to the payment processor. So decryption should happen in your PCI environment. It's pretty important that you treat the decrypted JSON as you would any other credit card, even though, like I said, the credit card number or the number there, the DPAN, isn't actually like the actual credit card number. You still want to treat it like it were a real credit card. Again, if you're not familiar with the way like the payments and card industry works, PCI DSS stands for Payment Card Industry Data Security Standard, and it's basically a bunch of standards that the card industry set up for how to secure your particular server and make it so that you can store credit card numbers in it securely, and they audit you to make sure that that you're compliant and everything. There could also be another server sitting in between your device and your PCI server, but ultimately you want to do all the decryption on PCI because, again, that's where the compliance is. That's where you should be storing your credit card stuff. So if there's another server sitting in between the Android device and your PCI server, then you just want to forward it on to your PCI server and do all the work there. Okay, so the final question before we get into all the code: why would you want to do this? The main reason is freedom. You won't be tied to a single payment processor. A lot of payment processors want to do tokenization and store all your credit card data for you. and that kind of ties you to that processor. So if you decide that, okay, we're going to go with Stripe, and then we're going to go whole hog on Stripe, and then all of a sudden one day you're like, I don't like Stripe anymore. I want to go to Adyen or something like that. Well, Stripe has all of your credit cards that you've generated over however many years you use them. So it's kind of difficult to then just up and move to Adyen or some other payment processor. So it's, I guess in general, most small businesses don't need to do this. It's more for like big people that are doing lots of card processing. Big companies that are doing lots of card processing probably have multiple payment processors because they've negotiated different rates between the payment processors. At Etsy, we have multiple payment processors, and we like to be able to switch between them if one goes down, which we've had some bad outages from some of our payment processors in the past. It's nice to then just be able to flip a switch and then forward all the traffic on to our other payment processor. Whereas if one houses all of our tokens, then we can't just flip a switch and divert all traffic to the other one. So it just kind of prevents lock-in. But in general, most companies that are of like medium to small size do not need this. Payment processors can decrypt the Android Pay data on their own, and can keep all of the card stuff, all of the card information secure on their own servers. So then you don't have to fool with PCI compliance, which is kind of a pain in the ass. So just in general, a good rule of thumb is if you don't have your own dedicated PCI environment, you probably don't need to be decrypting Android Pay data. Just leave it to your payment processor. Okay, so now that all of the initial like groundwork's out of the way, we can talk about how to actually get set up to do this. You have to use OpenSSL to generate an elliptic curve public key pair. And then you're going to take the public key, and that's what your app is going to use to then generate Android Pay data. And it puts it in what's called a masked wallet request. I haven't really dug into the Java code for an Android Pay app, so I'm not really sure what the masked wallet request looks like and how it takes the public key, but I'm pretty sure y'all can figure that out. And then the private key stays on your PCI server, and obviously you want to, like all private keys, you want to keep that pretty secret. Google provides some really great documentation on how to decrypt Android Pay. So if you actually are going to get into this, then they outline like the actual OpenSSL command to use to generate the key pair. And so you can just kind of follow along in that, and it's pretty self-explanatory. If you're relying on your payment processor to manage your decryption for you, then they'll give you the public key and they'll maintain the private key themselves. So the next step is parsing the inputs. So here we're actually going to take that JSON that we saw in the very beginning and parse it into usable variables. All of those JSON values are base64 encoded. And in this particular example, the merchant private key or the private key that we're storing like on our PCI server is also base64 encoded. This is these example values are pulled straight from a Java example that Google provides. So that's why they're just kind of like they're self-explanatory, I guess. So what I'm doing in this code is base64 decoding that the private key, and then the private key value is actually stored in what's called PKCS8, like a PKCS8 format. So we can use the X509 standard library package to then parse that into a private key. And then we can use type inference to make that into a elliptic curve private key. So that's what those first 5 lines are doing. And then the next one, it's just taking the JSON values and base64 decoding them into their into the variables that correspond with what they are. All right, so now that we have those variables, we're going to verify that the public key, the ephemeral public key, which is the we base64 decoded it here. We're going to verify that it's on the correct curve that we use for elliptic curve for this particular Android Pay request. So Android Pay uses a specific curve in the elliptic curve cryptography, which is what's called a P256 curve. I'm not really sure how familiar you all are with elliptic curve cryptography. I'm not super familiar with it myself, but basically there's a bunch of different curves you can use, which are just kind of, when you look at them, they're kind of like a scatter plot of like, I don't really know how they're a curve, but somehow they're like generated by some algorithm. And then your public key is just an XY coordinate on that curve. And your private key is like an offset of that XY coordinate. So here what we're doing is we're going to verify that the XY coordinate of the public key that we just got out of the JSON is valid. And we're going to make sure that, it's actually on the P256 curve, and that none of the values are like in a weird state, like they shouldn't be negative, or they shouldn't be like in, I don't know, a weird value. It should just be a standard XY coordinate in the positive. So what we're going to do is just do some comparison there, make sure that they check out, and then if they do check out, we're going to actually create a public key instance, which again, we're using the ECDSA package that's provided in the standard library, and we just plug in the curve, which is just P256. It's from the elliptic package, and then the X and Y coordinate, and that's all we need to create EC public key. So now we're going to take that public key and we're going to generate a shared secret from it. And you find the shared secret by using the public key's coordinates and then multiplying that by the private key scalar value. So again, the private key is just like an offset on the curve, whereas the public key is an XY coordinate. So that's basically what we're doing here. We generate the shared secret by taking the ephemeral public key, which I guess I should also state that the ephemeral public key is different from the elliptic curve public key that you generate using OpenSSL in the beginning. They're two different things. The ephemeral public key is like a one-time use thing that is derived from that original public key, but is not the same. So the ephemeral public key is like just used for this one transaction and probably will never be used again. That's why it's like ephemeral. If it, if the transaction fails, then you'll never see it again. So what we're going to do is generate a shared secret. So we're going to take the ephemeral public key and scale it by the private key that we generated. So the ephemeral public key is passed to us in the JSON. The private key is the private key that we actually maintain on our PCI server. And I'm not really sure why we dropped the Y scalar value and only used the X as the shared secret. That's just how it worked. So that's not really clear to me. And then we're going to use that shared secret, and we're going to concatenate it to the ephemeral public key again to create the input keying material. So we're taking the bytes of the public key and marshalling that into that IKM, the input keying material variable, and then we're taking the shared secret bytes and writing that to that same buffer. So it's kind of weird what we're doing. So we're taking the ephemeral public key, we're multiplying it by the scalar of our private key. Then we're taking that result and appending it to the input or to the ephemeral public key. So it's a little weird that that's kind of how it all works. Then we're going to use the input keying material, this IKM variable, in the next step to generate our what's called our MAC and decryption keys. And then those are used to then verify the JSON is valid and then decrypt it. So in order to do that, we do what's called HKDF, which stands for HMAC key derivation function, and it's actually a like a standard thing. If you look at the Google documentation, they outline exactly the steps involved in doing HKDF, and HKDF's used on all kinds of things. It's not just Android Pay specific. We use HKDF for a lot of different things. And then we're going to use the SHA-256 hashing algorithm with HKDF. So HKDF is hash independent. So you can use whatever hashing algorithm you want. For Android Pay specifically, the documentation says you use the SHA-256 algorithm. HKDF is a two-part operation. So the first operation is what they call the extract step. And if you look at the documentation for HKDF itself, it goes into some detail about it. But basically, all you're doing is taking the input keying material and a salt, and you're HMACing them together. And according to the Android Pay documentation, the salt for this particular thing is just 32 or is 0, or in our case it'd be 32 0 bytes. So all we do here is we just generate 32 0 bytes. We rely on Go zeros out any kind of buffer whenever you create it automatically. So we just create the buffer, rely on Go's behavior of zeroing it out, and then we HMAC the salt, and then we dump in the input keying material bytes, and then from that we get our pseudo random key, which is the PRK variable there. So the second part of HKDF is what's called the expand step, and this step's a little bit more labor intensive. So then you loop over the values you get, or the input, or no, the pseudo random key. Sorry, you loop over the pseudo random key, and you append, you HMAC that, and then you write in some additional values over during each iteration. Fortunately for Android Pay, since we're using a SHA-256 hashing algorithm, our buffer is long enough, or is small enough, that we don't actually do any iteration. It's just a single pass through. So I took all the iterating of the expand step out, and so it's just straightforward. You HMAC the pseudo random key. You write in the ASCII value Android, which is straight from the Android Pay documentation, and then you write in a single byte of 1 there, because that's part of the HKDF algorithm. As the iterations increase, then your byte value increases. So if we were to iterate again, then the byte value would be 2, but it would stay Android as the ASCII stuff. So that HMACing all that stuff together then gives us a value that we call T. The name T is derived straight from the HKDF like documentation. I don't really know why they call it T, but they do. And so we actually take that T value and split it in half. And the first half of it is the decryption key. The second half of it is the MAC key. And so if you look in the Google's Android Pay documentation, it actually says like 128 bits 128 bits of it are used for the decryption key, 128 bits are used for the MAC key. So since we're using bytes here, that corresponds to 16 and 16. So now that we have the decryption and MAC keys, we can actually, we're pretty much ready to start to do the decryption. But before we do that, we want to verify that the JSON is legit. Again, we're dealing with like money and payments and stuff, so you don't want to just go decrypting these values if somebody's like has screwed with the JSON and might be sending you some invalid JSON. So we take that MAC key that we just generated and we HMAC that. And then we add in the encrypted message, which again, we get that straight from the JSON. That's just the base 64 decoded JSON value. And we then compare the tag verify value with the tag value. The tag value is the other thing that gets sent in the JSON at the very beginning. So if those two things are equivalent, then we know that our JSON payload is legitimate and we're clear to decrypt it. One important thing here is we're using HMAC equal, which is a constant time comparison. You don't want to just do like an equal here because you could put yourself at risk of timing attacks, which is kind of like if somebody could just keep changing tag value and seeing how long it takes you to actually like decrypt everything. And if you're just using equal, then it will take longer or shorter depending upon how the comparison shapes out. So by using a constant time comparison, it's always just going to be the same amount of time, so you're not really leaking any information to an attacker. And also, you want to make sure that you compare the two tag values before you even attempt to decrypt the encrypted data, because again, it's it's card data, so you don't want that stored in a buffer or something and then you find out that the tag values aren't the same, so somebody's clearly screwing around with something, but I've already decrypted it, it's in a buffer somewhere. Maybe somebody could grab that somehow. So we've verified that the tag value that was passed to us is good. So the whole JSON payload is legitimate. So now we're going to decrypt it. And the Android Pay documentation just says you use an AES 128 CTR mode with a 0 IV, no padding, and the symmetric encryption key. So AES 128 CTR mode, I read about what they were, but I don't exactly know what it all means. Again, I'm not an encryption expert or anything like that, so I just kind of followed the documentation for Android Pay. But it fortunately Go provides some great libraries or great packages in the standard library. So what we do here is we create this new cipher using the symmetric encryption key, where did we get that? I think no, that's not the decrypt key. I don't think. Whoops. I think that is the decrypt key. So I think my notes are messed up here. I think that should be our decryption key. And then we use the size of the encrypted message to allocate a buffer for the decrypted message. So one thing we're relying on here is that the encrypted message is larger than the decrypted message. So if we allocate a buffer that's the size of the encrypted message, and then we dump the decrypted stuff in there, we can be reasonably sure that the decrypted data will fit. We're not going to have a buffer overflow or anything because we allocated more than we actually needed. So what we do here is just make that decrypted buffer, and again, we just allocate the length of the encrypted message, and then 0 IV just means 16 16 zeroed bytes. So again, we just rely on Go's behavior of zeroing out a byte array. and make that. Then we dump all those things into our cipher stuff and XOR them together, and it should populate the decrypted buffer with our decrypted data from our encrypted message. So there are a couple limitations with their approach. One is that there's really no defense against replay attacks. So if somebody intercepts one of these Android Pay messages and then lets it go on, and then a few seconds later they send that same one, they could just keep sending them to you because there's really no time component involved in this. So you kind of have to build in your own time component to kind of verify that what is being passed to you you didn't just see, and you should probably be storing these values after like the encrypted token. That way you make sure that you don't ever see it again, because if you see it again, then it's probably not legitimate. And once you've decrypted the token, again, going all the way back to the beginning, it doesn't actually mean that money's changed hands. You've just decrypted the data. You then need to send it to a payment processor who will talk to the card networks and actually move the money around. So I have a working example. I guess I can just click the link. Cool. So this is going to take, again, this is like all of the values that you see from that I got from the Java code, and these are what we had in the very beginning, and then you can see like each part of it is what we already went over in the how step. And so if I run this, cool. So it decrypts to plain text is the. I don't know why they chose that. They just did. So if we change any of these values here, so like let's change this E to an A and run it. Yeah, invalid cryptogram. So it detected that the tag value wasn't equivalent to what it should have been. And we can change any of this stuff. So if we change this to, is that a B? If we change that to an A, I think we'll get an exception. We might get a kernel panic. Oh no. Oh, okay, it couldn't unmarshal the ephemeral public key. And then we'll turn it back, and cool. So that's about it. Thank you. Any questions? Y'all can clap if you want. I think she's handing it to him first.
You showed off a lot of libraries.
Yeah.
Were those things that were in the Android Pay documentation already linked, or did you have to go searching elsewhere for them?
No, I had to search for them. I mean, most of it's pretty self-explanatory. Like I said, I did this in C first, so a lot of it, like, I just kind of looked for equivalents to what OpenSSL had, and then just kind of dug through all the Go documentation. I mean, fortunately, like I said, it's all in the standard library, so the documentation's pretty good, and there wasn't too much that was like hard to figure out. I mean, sometimes I'd have to actually go to the source to see exactly what they're doing. I had to do that for like the cipher stuff to kind of figure it out. But in general, yeah, the Android Pay documentation just kind of was like, yeah, you use this thing, and then I would go look in the in Go's standard library, and they were like, yeah, and here's that thing. And I was like, cool, all right, perfect. We had a question up here. Oh, yes, okay, cool. Anything else?
Any other questions? So what would you say was your biggest reason of converting to C to Go? Why did you choose to use Go?
I mean, I've been tooling around with Go a lot. I just like the language. So, and once I had actually written all the code out, I was just shocked at how much easier it was in Go than it was in C.
Did you do any benchmarks of?
No, actually, I didn't. I should. That's
I was just curious how it turned out.
No, that's a good idea. Actually, I haven't done any benchmarks to see what the performance is, if there's a performance difference or not. I'm not sure. Cool.
Thank you.
Thanks.
All right. Tom, where's Tom? There you are. Great. While Tom's getting set up, if you guys want to get seconds, help yourself. He just plugs in here.
Yes, yeah, it's all good.
Okay.
Yep. Cool. I think I'm just about ready to get started. Can everyone hear me okay?
Yes.
Excellent. Cool. This last couple of people take the seats. Okay, so I'm going to get started. So, how many people here develop microservices? Most people. And how many develop microservices in Go? Because it's great for microservices. But testing microservices can be a bit of a pain. So tonight I'm going to be talking to you about a tool that we developed at Yext to make things a little bit easier when we're developing microservices on our local machines. So a little bit about myself. I'm Tom. I'm an area tech lead at Yext. The link to my blog and my Twitter. My blog really needs updating. I haven't written anything in a while, but well. A little bit about Yext. We are a digital knowledge management company. So we primarily work with location data. So a company with a lot of stores will provide us with the information about those stores, and we will make sure that's up to date all across the web. So Bing, Yahoo, Google Maps, all those different places, the location data is all up to date, the hours are correct, the addresses are correct, phone numbers, etc. We've got about 100 engineers and always growing. We are also hiring. they'd be remiss not to mention. We have over 200 microservices in both Java and Go. We're using more and more Go all the time. And we have a number of open source projects. A good chunk of those are also written in Go. So things that I'm going to be talking about tonight, I'm going to introduce Edward, the tool that we built. I'm going to explain why it was built, go through some key concepts and features, and then do a live demo, which I hope works. So I think we can all agree that unit testing is great. Go has some fantastic unit testing tools, and everyone's really eager to automate testing of their stuff. But that can mean that we ignore manual testing. Manual testing is absolutely critical for good development because it allows you to see what a real user would see and try out your software in a real environment. And to do that, you often need to run your services locally on your development machine. So this is where Edward comes in. Edward is a microservices manager for development. It will build and run your microservices on your local machine. It's implemented in Go, and it is completely open source. It's primarily open source, so we can use Go Get, because doing that with a closed repo is apparently really hard. Mac and Linux support at the moment, primarily because we used to use Bash very heavily. We're using a bit less of that now, so hopefully Windows support will be coming soon. Does anyone actually develop on Windows? They exist. It's great. So we tried to keep everything simple so you can install and update using Go Get, and that will just get you up and running and give you the Edward command. So why did we build Edward? Well, to tell you that, I've got to go through a little bit about our infrastructure. As I said, we've got hundreds of services in a mixture of Java and Go. Now, with Go, you can build and run your services in just a couple of lines, one to build, one to run, or combine the two. With Java, a little bit more tricky, but we have an in-house build tool called ICBM, which allows us to do a build of our Java services and all their dependencies with a single command. We also have a number of third-party services that we rely on, RabbitMQ for messaging and HAProxy for routing. So running all of this can be a bit of a pain. We have an office environment to help out. So it's a development environment on servers in our office with one instance of all of our services, a fully populated database full of test data. And so if you run one service locally, it can discover all the dependencies it has. It knows where to connect to things within the office environment, particularly for the database, because our database is absolutely huge and contains a lot of seed data, so we can't really copy that around willy-nilly. But if you want to be testing more than one service, you're going to need a more complete environment. So let's say you're working on two separate services, an RPC server and its consumer, and you want to see how they behave as you change things. Now, in our case, we need to have a few local services running to authenticate locally. So if you're testing the UI, you need to be running our admin service, our UI service, our users service. If you want to track events through RabbitMQ, you have to be running that locally, otherwise you've got to sift through all the events that are going through the Office system. And if you want to trigger a batch job on a worker, you need to isolate that from the Office system, because otherwise someone else could pick up your job, or you could get everyone else's job and you don't really know what's going on. So we need a local environment, but there's kind of a problem with getting that set up. Because when I first joined Yext, the way we did it was to type in the command to launch your service, open a new tab in the terminal, enter the command for the next service, command error's out, you got to type it again, go back to the first tab to make sure nothing went wrong, realize you forgot to start the message bus, kill your first service, and repeat this 10 or more times. In the case of the product that I work on, we have to start at least 15 different services to have an isolated environment to run. So this was pretty onerous. What we ended up with was a very slow startup when we were switching tasks, and everyone ended up writing their own scripts to do this. So someone would have a set of scripts that would just run the services that they needed. And that made onboarding difficult because you couldn't ask different people the same questions, because everyone would have a completely different answer for you. So we built Edward to simplify this. So to launch services with Edward, you just use one command, Edward start, and then the name of your services. And then it will run through them all, start everything up, return you to a clean terminal, and everything's running in the background. So Edward will manage everything for you from that point on. So this means that we can spend more time working on our actual code. We're not going to make quite so many mistakes starting things up, so we're not going to have any misleading results. The cognitive load's lower because you only have to remember one command, and it makes onboarding easier because we have a single document that tells people how to use Edward. Here are the key concepts. Groups and services are the main entities that Edward works with. A service is something that you can build and launch. It'll typically be long-running, like a daemon, and it will likely listen on one or more ports. It will also log to the console so that you can get output directly from the service process. Now, a group is unsurprisingly a group of services. It does everything that a service does, but to multiple services in order. So you can start, stop, restart, and log. The basic commands that we have: Edward start will start up a set of services or groups. Edward stop will stop them. Edward restart will stop, then start the services. And Edward tail will output the logs and follow it for as many services as you need to see at one time. A little bit under the hood of what happens. When you start a service, it will run the build command that's been specified for your service under the correct path. If that errors out, it will display the output and exit. If it succeeds, it will start a runner process, which will change into the service path, start running the service, redirect the output to a log file. If it errors, it will display the error and exit, but if it doesn't error, it will wait until the launch conditions for this service are met. Now, by default, that is, this service is listening on a port, and that is how we consider that a service has started and is in reasonable health. Stopping a service, you can configure a command to explicitly stop a service. So, for example, for running RabbitMQ, you have to run a control command that will shut it down. If there's no stop command, or if that fails, it will try sending sigint to the process. If that times out, it will then send sig kill. So everything will die eventually, no matter how hard we have to push it. Restarting, as I mentioned, involves stopping the service and starting it. Stop, build, launch. A little bit about how we configure projects in Edward. We have a file called edward.json. And Edward will look in the current working directory and then every parent directory down from the root to find the config file. So that means that no matter what directory you're in within your project, you can manage your services with Edward. You can also override this with a -c flag if you want to use a different file name, or you want to use something that's completely outside of your hierarchy. General structure, you'll have 3 arrays. One for imports, which is other edward.json files to include additional groups and services, an array of groups, and an array of services. So let's look at an absolute minimal example to run a single service with Edward. So pretty simple service. I think we've all seen an example like this. Listens on port 8080 and will output a message with the path that you're browsing on. So that's single standalone file. And we can run that using Edward with just this bit of JSON. So we have a single service called simple. It only has a launch command, so it doesn't need to do a separate build step. So if you do Edward start simple, it will execute go run main.go, and we'll leave that running in the background for you. But we have over 200 services at Yext, and we didn't want to do all this by hand. So we introduced the concept of a generator. So you can generate configuration in Edward using the eponymous Edward generate command, very cryptically named. Now this will automatically build config for services based on Go, ICBM, Docker, or proc files from any directory under your current working directory. So if you have all your projects checked out, it will search through all of those to find any services that you can run. You can specify specific services you want to generate, because you're not likely to want to generate them all in one go, and it will add it to the current edward.json file. You can also ignore files in the same manner as a git ignore, because particularly with Go, the way that it determines if there is a service is just by looking for a main package. So if you have a command line application as well, you don't want to try and run that as a service. So you can exclude things that you're aware of. In this case, this is excluding everything from my Go path except for things within my own GitHub setup. We also do hot reloading. Well, not really hot reloading, it's more warm reloading. I spent about 2 hours looking around online at various times trying to find out what the definition of hot reloading is, and no one actually agrees on this. But what Edward does is it will watch directories and it will restart your services automatically when files in those directories change, just using fswatch. So in this case, my service has a watch set up for directory 1 and directory 2. So if any files within those directories change, that service will get restarted. We exclude everything in directory 1 exclude. So for example, if you're using a framework and that auto reloads your templates, you'll want to exclude those templates from the Edward restart. We also do warming up. So using frameworks like Play, sometimes resources aren't loaded until the first request comes in, which means that the first request that you make to a new service can actually take quite a long time. So in order to sort of kind of speed that up a little bit, Edward can send a single request to a given URL for each service after it starts up to warm things up, get everything ready so that when everything is started and you want to come in and do your testing, it's all set up and lightning fast. And we also wanted to make sure that everyone is using the same version of Edward as we put in improvements and we sort of change how things work. So we included update notification. Very, very simple thing. We tag all of our commits in Git, so we get a revision, a release for it. And then Edward will compare the current version to the tags on the Git remote and alert you if a newer version is available. So a little bit of the code for that. We have the update available function, which takes in the name of the repo and the current version that you're working with. It will return you a Boolean saying if there is an update available, a string with the current update version, or an error if something goes wrong. I've stripped out all of the error handling because I think we all know how that works. But at the top here, we make a call to execute the git command. So you need to have git installed. It will pull the list of tags from the remote. And then it will use the HashiCorp Go version package to build comparable version objects so you can determine whether your version is newer or older than the one that's on the Git remote. Okay, so I'm going to dive into a little bit of a demo here. And I'm going to have to unmirror my screen. Okay, great. Amazed that actually worked. So, okay, so I'm in my Edward example directory there. So if we do Edward list, we can see all the services that Edward has configured. So we have a group called app, and then 4 services, details of which I'll get into later. So let's start the app. Okay, oh, it's already running, so I'm going to stop it and then start it again. Okay, so that ran through, built everything, and started it in order. It happened very quickly because these are all Go services. So let's have a look at what we have. Well, let's find out what the port is first. So if we do Edward status, it outputs a list of everything that's running, its PID, and the ports that it's listening on. We also have a count of the number of lines we've got on standard out and standard error, so that you can see very quickly if something's going horribly wrong. So in this case, we have front, which is our UI, on 8080. So let's go there. Okay, so we have this lovely, simple Bootstrap UI with the unbelievably useful functionality of being able to tell you the last time someone pressed a button. So what we've got in the background here is we have the last touch service, which is an RPC service that will just tell you the last time that the button was pressed, and then you can send it a message to press the button. This is all rather whimsical. I wrote this last night while I was watching a Pete Holmes special. So we've got another couple of features going on here. So let's have a look at this Fibonacci one, and we get an error because nothing is listening on port 8082. So if we list our services again, we can see that we've got a Fibonacci service, so that's probably the one that we want. So let's start that up. We also have autocomplete, if you configure that correctly, so that all the service names will be completed as well as all the commands. So we start the Fibonacci service, reload this page, and we have a very similar sort of thing. We just hit next to get the next Fibonacci number in the sequence. So we can also restart services. So if we restart the Fibonacci service, and we refresh the page, it gets reset back to 1 because it was holding it in memory. So we also have this messages thing, and we have another service that we haven't got. So we have database Fibonacci front and last touch. The database is probably not going to provide the message functionality. We're probably looking for something like messages. It isn't in our Edward config, so let's try generating it. So this will display absolutely every service that it finds, including ones that are already in your edward.json. So we will continue with that. It's written it to our edward.json file. So if we actually look at that file, we have the group defined here with last touch and front, have each of our services with their build and launch commands. And if we scroll down to the bottom, it's added messages for us automatically. So let's start. Well, we're going to need the database for the messages. It'll take a second to start because it has to build a Docker container. And if we load up the messages, we have a bunch of messages we already created, so we'll clear those and start some new ones. So these are all being stored in the database. And let's look at how the database is set up. So we'll go down here. So a few things going on here. We specified that the path to the database service is within the database folder, and it has a single launch command which just launches a Docker Compose file. Because Edward is just calling command line applications, you can combine running things locally on your machine with running things in containers and get the best of both worlds. I really like using Docker Compose for setting up databases, but trying to run services that I'm developing on can be really slow. So this way, my services I'm developing on, I already have Go installed, so I can build and run them locally. It's a very, very fast development cycle. So we have this Docker Compose file, which specifies the database. So if we restart that, I think we'll need to restart messages as well to rebuild the connection. Okay, haha, it failed. So we got all the output here. So sometimes if you restart these things very, very quickly, it'll complain to you. So make sure it's stopped. And we'll start the database again. Give it a few seconds. Cool, and it started quite happily. So let's restart messages. And absolutely nothing has changed because the database persists within the container. So that right there is an overview of, oops, I've gone to the wrong thing. Aha. Use a separate display, that's what I wanted to do. Okay, cool. So we go back to slides. So that's sort of an overview of the different things that you can do with Edward. There's a few things that I've not covered here. For example, we manage services that require sudo. So it will prompt you for your password and then maintain that in the cache so that you can start and stop services that require sudo without having to do anything separate. And there's a few other things that we're working on that I'm going to get onto in a second. So a few third-party packages I'd like to call out because these are absolutely awesome. We used your fave CLI to manage the command line interface. A lot of people swear by Cobra, but this is my personal favorite. The GoPSUtil package provides a Go version of Python's PSUtil, and this allows us to work with PIDs. It allows us to determine the ports that are being listened on and access a whole bunch of the underlying OS stuff that isn't provided by the standard libraries. And UI Live allows you to rewrite portions of the console so that as we're sort of restarting things, it can say in progress and then replace that with done. So that's sort of like the underlying package that runs a lot of the command line progress bars that you see. And this is just sort of at a lower level so we can do something very, very precise for what we need it for. Okay, so I'm going to show a few things that we want to do in the future. I really want to include service dependencies, so you can specify services that another service depends upon. That will help Edward decide what order to start things in and will allow it to do better parallelization. Right now, we can build and launch 2 services at the same time, but we can't be launching 2 things at the same time because we want to know that things are started in a very specific order. If we have dependencies, we can determine what things are completely unrelated so that we can start different parts of the tree at different times. Improved Docker support. I found Docker extremely useful while using Edward. I've actually moved to using this for most of my personal projects as well. So being able to detect Docker Compose, we can only do Docker files at the moment because they're much simpler, and use the Docker API instead of command line interface, and have sort of a specific build and run code path just for Docker so that we can take advantage of a lot of the features that that provides. And also generator plugins. This is going to be a tricky one because this is Go. General idea would be to drop in an executable or compile some code directly on your machine so that you can bring in generators for different build systems, different languages for whatever needs that you or your company have. One thing we're working on at the minute is a generator for Bazel, which we're moving to away from ICBM. So if you want to give this a go or contribute, the command for installing or updating, we got the docs and the URL of the GitHub page. If anyone wants to take a picture of that, I'll give you a few seconds to do so. Okay, so any questions? Okay, so I think you were first there. I'll make sure it gets your name.
Hey. Oh, there we go. First off, this looks like a great tool. Thanks for working on it. Solves a lot of issues that we encounter at Vimeo, having a lot of different microservices, many of which have to depend on each other. And we don't love our solution for orchestrating it. How have you guys, this is not necessarily tied to Edward, but maybe relative, dealt with SSL termination of multiple services running at the same time? An example being if you have something on a web page that's making XHR requests and you need to run everything on HTTPS, have you encountered that? Have you worked through that at all?
That's not actually something that we've had to deal with at this point because we don't have many sort of like internal HTTP services that would have to be secured internally. Most things are being passed through as messages or through RPC that we deal with in our own way, and pretty much all of our SSL termination is done like right at the very end, so we have it like stuck on the CDN or whatever.
Cool, thanks.
Yeah, going down the end there.
I really like the tool. It's obviously open source. You guys use it at Yext. How many other users do you know, if you're aware, or other like external contributors to Edward do you have outside of Yext?
We've not actually had any external contributors yet, but I've spoken to a few people who've been sort of trying it out for their own projects. This is like kind of the first time I've spoken about this publicly. And until then, anyone outside of Yext who's discovered it, they've just happened to like find it on GitHub, and somehow maybe like 10 people have done that. But so hopefully in the future we'll have a lot of external contributors.
So I have like 2 questions. The first thing was you said that for onboarding new users that this helped them. Mm-hmm. But I saw that when you were doing your messages app, you still had to understand that you had like the dependency on the database. So say I'm like employee X and I have like all these microservices. It seems like you would still have to know what dependency each microservice had, right?
So for the example, I broke everything up into separate services so that I could sort of illustrate how you would build something up. Right. What would typically happen in a real case is that you'd have all the services you needed for like a particular feature set within a single group. So what we tend to do at Yext is we have a bunch of separate config files for each team. And the team leads are responsible, or make themselves responsible, for making sure that the groups are all up to date and contain all the correct dependencies. So, for example, if someone comes onto my team to work on the Pages product, all we have to tell them is run Edward start Pages, and that will start all of the services that they need.
All right, and then the other question is, with like your microservices and like specifically like you guys use Docker Compose, right? Do you guys run into issues where, you know, you might make a change to like an image, right? And then someone else doesn't have it, and then, you know, they start to spin up their service and it doesn't work because they're working on like a different tag than you're on. Have you like dealt with that issue? And if so, like how do you mitigate issues like that when working locally?
So would that be more like, where are these resources sitting? Is that like within the repo? And
right. I mean, you can have like your own maybe private Docker repo, or you might be using Docker Hub, right?
Okay.
And say like you have like 10 services, and you've just made a change to one service, and like someone else is like working on it, and they haven't pulled down your changes yet. Like how do you make sure that everyone has like the latest service?
Well, okay, so the use of Docker at Yext is primarily for testing.
Okay.
So we'll like spin up like sort of test harnesses and things like that using Docker. For most of the sort of third-party services, we just run them locally anyway.
Okay.
And contentiously, we have a mono repo.
Okay.
So that means that if you're synced up, you're going to have all the resources anyway.
Cool. All right. Thank you.
I was just curious, why is it named Edward?
I knew someone would ask that. Okay. So there was a British sitcom in the late 90s and early 2000s called The League of Gentlemen. I don't know if anyone's familiar with that. One guy remembers that show. There's a character in that called Edward who ran the local shop. And he was always asking people if they were local. So I would wholeheartedly recommend checking that show out because it is absolutely hilarious and kind of sick.
Hi, thanks for the presentation. I was just wondering, how would you change how you use Edward to manage services on remote machines? Would it be much different than what you just presented, or?
So are you talking like sort of remote debugging kind of things, or
I guess starting up and managing
Okay.
services on remote machines?
Yeah. So that's not a use case that we've kind of encountered. I've tended to find that, like, I mean, certainly for anything even approaching production, using the production tools that are already out there is, you know, more than enough. Like, I mean, I've been toying around with Kubernetes, and that's awesome. And I would recommend using stuff like that if you're going to be putting things on remote machines. Edward is definitely designed for just sort of like very, very short-lived test instances of stuff running on your local machine where you've got complete control.
Cool. And a follow-up question is just, what is the roadmap for Windows support, just as someone who's doing cross-platform service development?
So the aim is to just basically get rid of all of the bash dependencies. So previously, instead of having a separate runner process, we would just create a bash script to run the service. So that dependency is gone, but there's still a few little bits and pieces, and we need to come up with a decent story for sort of identifying when you're running on Windows and then deciding what to do with things that require elevated privileges. So some of that stuff is sort of tightly entwined, and we just need to kind of pull it out and modularize it.
So when you were doing the generation of the config, it seemed that it was saying, it was stating microservices that you already had in your config. When, if you wanted to make some custom stuff to those previous services that you already have, would it override it, or how does that whole point work?
No, not at all. So the only reason that it displayed the full list of services was that was everything that it found, and it hadn't yet checked if they were already in your existing config. So what it does after you've said, yes, I want to generate these, is it pulls up your config file, goes through the services, and then if something's already there, it'll just ignore it. So the database was actually already there as a custom service, and that wasn't picked up by the generator, and that was just left alone.
Okay. And you said that the Docker part hasn't been taken care of yet, right? So if you only have Docker projects, it wouldn't show up anything.
If you have Docker files, it will pick those up. It's just Docker Compose that isn't baked in yet.
Any other questions? Oh, there we go. Sorry.
Thanks. I may have missed it, but I know that it would restart the service if you put a watch on the files. If the service went down, would it automatically restart it?
That isn't something that it does at the moment. My current use of this, and mostly this is sort of like based on how me and a few other people at Yext have been using it themselves and have told me, is just if something goes down, then you kind of notice that quickly in your testing, and you'll run Edward status. It'll tell you that something's gone down, and then you can tail the log. Actually, that's something I didn't do. I didn't show the log tailing. So let me just show what we can do with that. So this is all still running. So this will just tail everything that's in the app, and it'll tell us which service it came from for showing the log. As new things come in, it will add those to the bottom of the list as it's tailing, and you just exit like that. So if you saw that something had gone down, it'd say like terminated or failed. You could see that it had a bunch of errors, and then you could just tail the log for it.
Hey. Do you see this as purely as a development tool, or are you thinking that this potentially will be orchestrating your services in production?
I definitely see this as a development tool. Yeah,
as a development tool, right?
I think that like the orchestration and production problem is something that a lot of very, very smart people who are far smarter than me have been working on for quite some time. Part of the reason that I built Edward was because local development wasn't very well served. And people hadn't really tackled this problem in any sort of depth. There are a few things that do similar sorts of tasks, but I saw that there was room for something that was just dedicated to local development.
Right. So there is never a concern that you're going to get a full positive of orchestration between these three services. You're running and developing, everything is peachy, and it's not how it's going to be deployed in production. And
yes,
then
exactly.
So you're not concerned about this.
No.
Check. No, that's cool. Cool.
No, it's a good question.
Just a question. I've been using Docker Compose for some of my local development stuff. What's the advantage of using Edward with Docker Compose versus just using Docker Compose and having everything in containers locally?
Really good question, and I knew someone would ask that. So I did spend some time trying to get some projects set up using just Docker Compose on its own, and I found it to be really great for very well-defined groups of services. But the problems that I came across were if you wanted to add something ad hoc, like just start up another thing and have it be part of your cluster, then that became a bit of a problem. And also you had to sort of roll your own rsync kind of thing to like rebuild things. And I found that to be a very, very steep learning curve. So the other slightly less good reason for this is that we don't really use Docker in production at Yext. So it didn't seem like it was worth going through all the effort of like getting everyone set up, getting everything put together. A lot of people are running older Macs that can't run the new version of Docker.
Thank you.
If you had a new service that requires some like custom configuration, how do you keep track of the Edward JSON file?
So what sort of configuration do you mean?
Well, you were saying how you might have dependencies and stuff. You might have what's it called. There was other options that you showed that didn't show up on the generated Edward JSON file, and so if one of those services would require one of those things, how would you pass that along to other developers? Would you have like your own repo just for the JSON file, or?
Yeah, I mean, because we use a mono repo at Yext, we can just have ours like at the root of the whole thing, which works for everyone. But what you can do is have Edward config files in specific directories or in specific repos. So if you have a single directory where you have all of the different repos for your different services, and you run Edward generate in that, and they all have their own edward.json file, it can pick up that config from there. Thank you.
Thank you.
Any other questions?
Thank you. Any feature of Go language that you use mostly in this, or you like about Go that really helped in this project? What was that about?
Certainly recently, the concurrency features have been a huge help, like trying to get sort of things building and launching kind of semi in parallel. Being able to use channels for tracking that and making sure that things are like ordered in the correct way and like blocking in the right places and not blocking in other places. It's made the whole thing a lot easier. If I tried to do this in Java, I'd still be doing it. So,
excellent. Thanks.
Any other questions? All right, well, let's have another round of applause for both of our speakers. And thank you all for coming. Franklin Angulo, who sets this up, he was traveling this week, but I sent him a picture of the turnout. He was excited to see you all. So we've wrapped up the talks, but please feel free. There's plenty of food, as you guys have seen. The bar is open, just on the other side there. Help yourself. There's cups, beer, wine, iced coffee. And feel free to ask more questions of the speakers, talk amongst yourselves, and enjoy. Thanks for coming, guys.